Hello everyone, myself Sahil G. Kuruji pursuing BTech in AI/ML at GM University. Today we are going to present the first assignment of machine learning and the topic for our assignment is KNN name base and decision tree for predicting spending category and our team consists of four members. They are Rohan DR, Rohit Itigi, myself Sali Kiroji and Shivkumar BC. Today, we are going to take you through an exciting machine learning classification project where we will predict customer spending categories like low, medium, and high based on their shopping behavior. This project will help business understand their customer better and inform marketing decision. Why is this important? In today's world, business generate huge amount of customer data, but having data alone is not enough. It needs to be analyzed and used effectively. One common challenge is identifying different types of customer based on how much they spend. For example, let me take a shopping mall or an e-commerce platform might want to categorize customers into spending groups like low spenders, medium spenders, and high spenders, where low spenders Low spenders, customer who shop occasionally and spend less, and medium spenders, customer who shop frequently but spend moderately, where high spenders, customers who make high value purchase regularly. By correctly classifying customers into these categories, where business can provide personalized offer and discounts, which improve customer loyalty by targeting them with the right promotion and optimizing market campaigns by focusing on high volume customers. To solve this problem, we will use three different classification algorithms such as k nearest neighbors is also called as KNN. It is a simple and initiative algorithm that classifies customers based on their similarity to their customers. And the second one is decision tree. It is a rule-based model that splits the data into different decision nodes, making it easy to interpret. And the third one is naive Bayes, a probability-based algorithm that is efficient for classification tasks, especially when working with categorical data. How we can implement and develop the models. First one, pre-process the dataset, which handle missing values, encode categorical variables, and normalize numerical data. Train the models. Implement KNN, decision tree, and naive Bayes classifier. And third one is test the models. Use test data to make predictions. And fourth one is compare performance. Evaluate each model using metrics like accuracy, precision, recall, and F1 score to determine the best one. We are going to explain the code, and my friend Shiv will explain the starting of the code.
So, hi everyone, myself Shivkumar, pursuing in BTech AML. So, here we are explaining this code. In the first line, it's import NumPy as NP. So, here it imports the NumPy library, which provides supports for arrays and numerical operations. In the second line, import pandas as PD. So, here it imports the pandas library, which is used for handling and analyzing structured data in the form of data frames. And next, import Seaborn as SNS. So here it imports the season library, which is a visualization library built on top of matplotlib. So in the next line, import matplotlib dot py, pyplot as PLT. So here it imports the matplotlib libraries, payload pyplot module, which is used for creating plots and visualizations. So in the next, so here from sklearn.model selection and import train test split. So this imports the train test split functions, which is used to split the dataset into training and testing sets. So in the next line, from sklearn.preprocessing, import min max scalar, label encoder. So min-max scalar, it is used for normalizing numerical features by scaling values between a specified range. So and the next, the label encoder, it converts categorical labels into numerical format. And in the next line, from sklearn.neighbors, import k neighbors as classifier. And here it imports the k nearest neighbors classification algorithm. It is also called as KNN. And next line from sklearn.tree imports decision tree classifier. So here it imports the decision tree classification model. And next from sklearn.naive bias import Gaussian NB. So here Gaussian NB it imports the Gaussian naive bias classifier. And next line from sklearn.matrix import accuracy score, precision score, recall score, FN score, classification report. So these functions are used to evaluate the model's performance. So the accuracy score it measures the overall accuracy. Precision score it measures the precision of positive predictions. And next recall score it measures how well the model identify positive instances. And next F1 score harmonic mean of precision and recall. And the classification report generates a detailed report of all classification matrix. And in the next line, it's a file file path. It's df is equal to pd dot read csv file path. And the file path it stores the location of the dataset on the user systems. And pd dot read csv it reads the csv file into a pandas data frame, allowing further data processing and analysis.
And here clean column names df dot columns equals df dot columns dot str strip. Here the line removes any leading or traveling white spaces from the column names in data frame. And why it's useful means sometimes columns may have extra spaces around their names, and if the data is from different sources which can cause issue when referencing the columns later. And here the check if customer id exists before dropping. If customer id in df dot columns df dot drop customer id axis equals 1 in place equals true. And here the if statement checks whether the column customer id exists in the data frame df. If customer id is present, it gets drop using df dot drop customer id in place equals true. The axis equals 1 argument specifies that you are dropping a column, not a row. And in place equals true means the operation modifies the data frame directly. And the useful of customer id means may not be present sometimes, especially if the data changes or doesn't exist, or it may doesn't have it. It checks prevents errors that could occur during a drop column. And handling missing values df dot drop na in place equals true. Here the line drops all rows that contain missing values in any of the columns, and drop na function removes rows with any missing value in them. And in place equals to ensures that the data frame is modified directly rather than the creating a new copy. And converting gender to numerical values. Here the line uses label encoder from sklearn to convert the categorical values gender column into numerical values. And label encoder dot fit transformer a df gender converts each unique gender value, for example, male and female, into integers 0 and 1. And many machine learning algorithms can only handle numerical data, so converting categorical columns like gender into numerical values makes the data suitable for models. And here df spending category equals pd cut df spending score 1 to 100. And here bins equals 0, 40, 60, 100, and labels low, medium, high. Here the line creates a new column spending category which categorize the spending scores into three bins low, medium, and high. Here PD cut df spending score divides the spending score 1 to 100 column into intervals defined by the bins arguments. Each spending score is then assigned to the label based on the range it falls into. And here the useful of this line is this transfer for continuous variable into a categorical one, which might be useful for classification, class, or segmental customers based on their spending behavior. And the next part of the code will be explained by my friend Sahil.
Here, class count is equal to df spending category value counts. It checks how many customers belong to each spending category like low, medium, and high. And in the next line, if customer ID, and in the next line, valid class is equal to class count greater than one index. If any category has only one sample, it is removed. And in the next line, df is equal to df spending category is in valid classes. Keeps only the categories that have more than one customer to avoid errors in a model. These are important because machine learning keeps only the categories that have more than one customer to avoid errors in a model. And in the next slide, and in the next slide, scalar is equal to minimum scalar, minimum max scalar, df, age, initialize a minimum max scalar object. And in the next line, df, age, annual income, k dollar, spending score 1 to 100 is equal to scalar dot fit transform, df age, comma annual income, spending score 1 to 100. It applies minimum, maximum scaling to age, income, and spending score, and it transforms all values between zeros and ones. It performs better. Well, all features have a similar scale. Here, age and income and spending score have different ranges. So, scaling ensures fair comparison. And in the next line, x is equal to x is equal to df dot drop spending category axis is equal to 1. It defines x is also called as features and y is called as target variables. Here, x contains all customer details except spending category, which is the label. Y is equal to df spending category. Y stores spending category, which we want to predict. Here, we separate x and y before training. X is called as input data, which is used to predict, and y is also called as output. Actual result we compare with prediction. And in the next line, x train, x test, y train, y test is equal to train test split x comma y comma test size is equal to 0.2. Random state is equal to 42. Stratify is equal to y. It splits the dataset into training, which is 80%, and testing, which is 20%. Uses train test split from skitlearn to split the data. Here, random state is equal to 42. It ensures that every time you run the code, you get the same split. Stratify is equal to y, which ensures that each spending category, low, medium, and high, has an equal proportion in both training and testing data. Here, training data, which is X train and Y train, which is used to train the model. Testing data, X test and Y test, is used to evaluate model performance. Stratify is equal to Y, prevents imbalanced dataset, ensuring all spending categories are equally distributed. And my friend Rohan will explain the remaining part of the code.
Thank you, Sahil. I am Rohan Dr. I am pursuing BTech AML in GM University. I am now explaining the training of the KNN model. KNN stands for K nearest neighbors model. As you can see in the first line, the KNN is equal to K neighbors classification, N neighbors is equal to 5. It creates the KNN classifier with the K value 5, meaning it consider the 5 nearest neighbors for classification. And in the next line, KNN dot fit X train comma Y train. It trains the KNN model using the training features X train and their corresponding labels Y train. And in the next line, KNN pred is equal to KNN dot predict X test. It uses the trained KNN model to predict labels for X text, that is test data. It stores the predicted table in KNN pred. And in the next, training the decision tree model. As you can see in the line, dt is equal to decision tree classifier random state is equal to 42. It creates a decision tree classifier. The random state is equal to 42 ensures the reproducibility. And in the next line, dt.fit xtrain and ytrain. It trains the decision tree model using xtrain and ytrain. And in the next line, dt_pred is equal to dt.predict xtest. It uses the trained decision tree model to predict the labels for xtest and stores the predicted labels in dt_pred. And in the training the naive Bayes model, the naive Bayes model, I'll give a simple explanation. It is a model. It is a machine learning algorithm used for classification, sorting things into categories. It is based on the probability and helps predict the category of something based on the past data. And in the naive Bayes model line, NB is equal to Gaussian NB. It creates the Gaussian naive Bayes classifier, which assumes features follow a normal distribution. And in the next line, nb.fit xtrain, ytrain. It trains the naive Bayes model using xtrain and ytrain. And in the next line, it uses the trained naive Bayes model to predict labels for xtest and stores the predicted label in nbpred. And defining the evaluation function, def evaluate model ytest ypred model name. It defines a function evaluate a model that takes ytest is a actual labels, ypred it predicts the labels from model, and the model name is the name of the model being evaluated. And in the next line, it prints performance of model name. The print name is the prints it prints the name of the model. And in the next line, it uses the classification report to print a key evaluation metrics. The metrics are precision, recall, F1 score, and support. In the precision, it predicts positive how many predicts positive are actually correct. In recall, how many actual positives were correctly identified. In F1 score, the balance between precision and recall. The support, the number of the actual samples in each class. And in the last, evaluating all models. Evaluate model ytest KNN print KNN. It calls the evaluate model to print performance metrics of the KNN model. In the next line, evaluate model ytest dtpred decision tree. It calls the evaluate model to print performances metrics of the decision tree. And in the last line, evaluate model ytest nbpred and naive Bayes. It calls the evaluate model to print performance matrices and naive Bayes model. Thank you. And result and conclusion will be explained by my friend Shiv Kumar.
So this is the input we have taken. Here we have taken five attributes. They are customer ID, gender, age, annual income, and the spending score. And also we have imported the CSC code into our input. And the results of this path is. So this is the output of the project, and in the output of performance on the KNN. So here all matrices are 0.00, meaning the KNN model failed completely because the data set is very small, only four test samples. And the next KNN relies on neighboring data points, but since the data set is tiny, it might not have enough relevant tables to make good predictions, and data might not be well distributed, making KNN ineffective. So the conclusion part is the KNN is not suitable for this classification task with a very small data set. And next, in the output of the decision tree performance, they are 100% accuracy. So here, decision trees are very flexible and can fit the entire data set perfectly, especially on small data sets. So since the data sets have only four test samples, the tree can memorize exact patterns and correct classify all test cases. This might indicate overfitting, meaning the model performs too well on the training data, but might not generalize well on new, larger data sets. So the conclusion part is it works well here, but might overfit on large data sets. And next, the output of the naive bias performance. So this is also 100% accuracy, And here the naive bias assumes independence between features and works well when data distribution is simple. Since we have only four test samples, it correctly classifies all of them. So the confusion part of this is it works well in this case, but with the large dataset, performance may drop if the independence assumption is incorrect. So this is the output of our code. And thank you for this is the end of our project. And thank you everyone. Thank you my teammates, and thank you GM University for giving the opportunity for presenting our project. And thank you our mentor Shivaranjan for providing the opportunity for explaining the code. And so yeah, this is about our project.